Good evening, everyone, and
Good evening.
welcome to the session 5 of the
Okay.
Siyanqoba training program for seniors. Would you please take your microphones off? Um, because um, if you have to speak to me, we will speak at the end of the session. Uh, we don't have time to have any discussions in between. That is the usual process. Thank you very much for cooperating regarding this. So today we are going to do um, problems. We want to continue with the problems that we started with last week or the week before that. Um, Basically, just one moment, please. My apologies for that. Um, all right. So what I was saying is that last the last time we met, we started with problems on distance, time, speed, and so on. And we did a few problems, and there were quite a few which we didn't do. And what I'm going to do today is continue with whatever we did in session 4, these problems, and then thereafter we'll go into problems which um, involve counting, all right, what we call permutations and combinations, or counting. So let's go straight away into this because we're already at 5 past 5. So let's have a look at the very first question. This question says, a loaded truck travels from Durban to Pietermaritzburg at an average speed of 60 kilometers per hour. So the speed from Durban to Pietermaritzburg is given, that's 60 kilometers per hour. So if we just draw a little diagram like this to denote this thing, the Durban to Pietermaritzburg, and it's going at 60 Ks. And after unloading, returns by the same route at an average speed of 90 kilometers per hour. So on the return journey, it's 90 kilometers. The question is, what is the average speed of the truck over the whole journey? So the upward climb is 60 and the downwards is 90. You might be tempted to say the average speed must therefore be 60 plus 90 divided by 2, because that's the average of two numbers, which gives you 75. But it turns out that 75 is not correct, and we will see why. Okay, so first just decide what do you mean by speed? So the basic equation is distance is equal to speed times time. So we don't have the distance here, we have the speed. So let's assume it's the same distance upwards and downwards. Let's suppose that d is the distance between Durban and Pietermaritzburg. So let be the distance between Durban and Pietermaritzburg. So then, what is the question? What is the average speed of the truck for the whole journey? All right, so it means the question is the whole journey, the distance is 2d. So you want average speed. The speed is equal to the total distance, which will be 2d over the time taken. Because the average speed is distance divided by time. And the total distance, for the whole journey, the total distance is 2d. So you need to know how long did it take for the full journey. All right, and for that, you have to work out the upward time. Sorry. The time that it took for the upward journey. And that time is that distance divided by its speed. So the distance there was d, and the speed in the upward journey was 60. So this is the time that the truck took to reach Pietermaritzburg. On the downward journey, the same distance, but the speed now is a little bit faster. It's d over 90. And the total time will be the time, the upward journey, plus the time for the downward journey. Okay, so we have to work this out, the total time. And this is the sum of two fractions. Common denominator, 60, 90. You notice that 180 is 60 goes into 183 times, and 90 goes into 182 times. So the time taken is 5d over 180. And this is in hours, because you've got kilometer per hour, and time will have to be in hours. So therefore, the speed that we are talking about is 2d divided by time. The time is 5d over 180, and so that's 2d times, when you're dividing a fraction, you invert 180 over 5d. The d's cancel. The 5 goes into this 36 times, and you have 2 times 36, which is 72. And that's the speed. So the units for the speed is kilometers per hour. We must write down the units in each case. Distance is in kilometers, time is in hours, and speed is kilometers per hour. So this is the answer to the question. So it's not 75, see, it's actually 72, which is a little bit surprising, but that is because we are using the formula for the speed, and that formula is given by distance over time. So you can't just guess, you have to use precisely what the relevant information is and how to do it. Okay, so let's get on to the next question. This is again, as you see, session 4, question 11, which I did not tackle. last week. Okay, here you got Farida and Sumaya complete a 100-meter race. Right, so you got two people who are running a 100-meter race. Farida crossed the winning line when Sumaya was still 20 meters short of it. Okay, so I've drawn a picture here. This is the start, as you can see. And there is 100 meters, right, from start to end. And Sumaya had only done, Sumaya was still 20 meters short of it. So Sumaya was 20 meters behind the end. Farida was here, and Sumaya was here, 20 meters. So in other words, Sumaya would have traveled 80 kilometers. I'm sorry, 80 meters in the same time that Farida traveled 100 meters. Okay. So in other words, whenever Farida travels 100 meters, Sumaya will travel 80 meters. So that tells you the relative speeds also. It means that Sumaya's speed is smaller than Farida's because she does 80 and the other one does 100. So it's 80 over 100 or 80% of Farida's speed. So Sumaya only travels at 80% of Farida's speed. Okay, let's go on here. Farida wanted something more challenging, so it was agreed that Farida would start 20 meters behind the starting line. So I've got a picture here. There's your starting line. Yeah, there's a starting line here. And she gives Sumaya a head start. So Sumaya is at the starting line. There's the starting line. And Farida is behind her. And they both ran exactly the same speeds in the first race. So now they both run, but now she's got a 20-minute head start. Right? The question now is, where was Farida and Sumaya when the winning line was crossed by whoever arrived at it first? So we want to know what happened here. Who won the race? Farida was 20 meters behind, note. So Farida runs 120 meters altogether, while Sumaya runs 100 meters. So let's see now. If you take this situation, I told you that when Sumaya runs 80 meters, and Sumaya runs 80 meters, then Farida runs 100 meters. So suppose we see what happens when Sumaya runs 80 meters. Now, because of the 20-minute start, Farida will run the same 100 meters when she does 80 meters. So Farida and Sumaya are at the spot here, 80 meters from the start. Right? So when Sumaya does 80, Farida does 100, and because of the 20-minute start, they will be together at the spot. So Farida and Sumaya are together 20 meters from the end. So clearly Farida will win because she's the faster runner. She overtakes her. But now the question is, where and Sumaya were when the winning line was crossed? Okay, so when the winning line was crossed, Farida is here. So let's have a look at this scenario, this last 20 minutes. Let's change the scale here a little bit. So you got 20 meters. So Farida won, so she is here. And Sumaya, so the question is, where is Sumaya? So now, that's a nice, interesting question because, so Farida, she runs 20 meters. And you want to know F equals 20, S is equal to what? So how how many does Sumaya travel? But we know that when F is 100, Farida travels 100, Sumaya does 80. So we got a good idea. So in other words, you can see now clearly when Farida runs 20 meters, when she does 100, S does 80. 20 is 1/5 of this. So Sumaya will travel 1/5 of 80, or 20 over 100. It's a ratio sum problem. So, or proportion. So Sumaya will do 1/5 because the distance covered is only 1/5 of 80, that is 16. So Sumaya has run only 16 meters. So where were they? So we have to describe it in terms of the finishing line. So she ran 16, so Sumaya was 4 meters from the finishing line. So the answer is Sumaya was 4 meters from the finishing line. And Farida was at the end. Farida wins, and Sumaya was 4 meters from the finishing line. Okay, so we have not used any formulae yet. It's just pure logic and proportion. That's what we did. It said nothing about distance is speed times time or anything like that. Right? This is a purely proportion problem. So it's an interesting problem. Okay, so let's get on to the next one. All right, so here, the third question, Savitri noted that a train to Musenberg took 8 minutes to pass her. So there it is. Okay, so this girl here, she's, oh, oops. She is watching a train, and she sees this train is passing her. So the train to Musenberg. So it goes like this. And to pass her, the train has to travel its full distance. It takes 8 minutes. So in other words, it passes her. It takes 8 minutes to do this. So what does this mean? It means that the length of the train is the distance. So here the distance equals length of train. Because you want the full train to go right past her. So this is the driver. He's still sitting here. And so the length of the train to Musenberg is, well, that's the question now. What is the length of the train to Musenberg? So let's call it X. All right. So X is the length of the train to Musenberg. Oh, okay, we're not calling it D, we'll call it X. Length of train to Musenberg. All right. And it takes 8 minutes to pass it. So now if you got the distance here and you got the time, so this here is in minutes. So, and the length of the train should be in meters now, obviously not in kilometers. So we'll say X meters. All right, so therefore the Musenberg train, the speed of the Musenberg train we'll call it the M train, is distance over time. And the distance is x over 8, and this is in meters per minute. Because it takes 8 minutes to pass here. That's the speed of the Muizenberg train. Now, a train in the opposite direction, so this is what I've got here. The train in the opposite direction, okay, now I'm saying that train, its length is y, right? So it's the same story. So the speed in the opposite direction, now that's going to Cape Town. We'll call it the CT train. So if it takes 12 minutes to pass it, so it's the same story, but now you've got the length of that train is y. As you can see, I'm saying it's y, and it takes 12 minutes to pass it. So that's the speed of the Cape Town train. So I'm taking it piece by piece. Instead of trying to work out the entire problem, I try to understand it piece by piece and try to see what conclusions I can make. Right? Now, the trains took 9 minutes to pass each other. That's a tricky one. Because, so you got, so let's have a look. Okay, you got it here. So to pass each other, okay, so let's start when the trains just meet. When they meet, and then after that, the one goes this way, the other goes this way. So we need to know what is the distance between the front of the Cape Town train and the back of the Muizenberg train, right? So to pass each other, what will happen is the total distance that is covered here now, when they're passing each other, the end of the X train will be here now, right? And the Y train will be here. And this is the tail end. This is the back of X train, the Y train, and that's when they pass each other, when the road backs are together and they move on. So in other words, the total distance traveled is X plus Y, right? Between the fronts of the train. So here, you got X plus Y is the total distance traveled, and that takes 9 minutes. All right, so let's do it this way. This train travels at x over 8 meters per minute, right? In 1 minute. So in 9 minutes, it will travel 9x over 8. Now, likewise, the Cape Town train, it travels y meters in 1 minute. So in 9 minutes, it will travel 9y over 12. So therefore, the total distance traveled, this x plus y, is actually, after 9 minutes, this has traveled 9x over 8. And this would have traveled 9y over 12. right? And the sum of these two is just the distance between these two. So it's supposed to be 9x over 8 plus 9y over 12. So this is the distance that is covered in 9 minutes. And the distance we are speaking about is the distance of separation. And that is x plus y. So now you have one equation with two unknowns. But they do tell you that the train to Cape Town is 150. So y is actually equal to 150. I didn't put that information in because it's easier to work with symbols like this. Now, if I want to get rid of the fractions, 8 and 12 here, I have to multiply by a common denominator, and 24 is the common denominator. 8 goes in 24 3 times. So let's just multiply by 24 on both sides. And here you have, when you multiply this by 24, 8 goes into 24 3 times. So it's 27x. And here, 12 goes into 24 2 times, it's 18y. So you got this, if you take the fractions out, you bring all the x's together. I got 24 and 27 here. Let's put the x's on this side. You got 3x. And here you got 24 minus 6y. 24y minus 18y. So I'm bringing all the x's to one side. And I know y is 150, you see. So therefore, y is 150. 150 times 6 is 900. 3x is 900. So x is 300. So x is 300 meters. Okay. So this is getting a little bit tougher, as you can see. Again, the idea is understanding what you mean by meters per minute. Right? It's just not a formula. You see, just in 1 minute it travels that means. So in 9 minutes, how far does it travel? Because that is what we are looking at. It takes 9 minutes to pass each other. And once you got that sorted out, then you can get your equation. And there's only one unknown here, because y is 150. You've got to put 150 right there, but I find it easier to leave the symbols as they are and make the substitution at the end. That's a useful trick. Okay, so let's just get on. Now, the next problem is the following. Now, listen very carefully because this is quite a tricky problem. It's a rather complex problem. So let's hope that you can understand this thing. Then, if you can't, you can always look at the recording at some time later, and you can go back over it again. A truck starts from point A towards point B. Okay, I got my. See, I always try to draw diagrams so I can see what's going on. So you got a truck which is going this way, and at the same time, a car starts from point B, and it moves. And when the car was halfway between A and B, okay, let me. I'll do the diagram there. Just I was jumping the gun there. So you've got when it's halfway between. So the car was halfway between the two. So these two distances are the same. When the car was halfway between A and B, the truck, okay, both of them moved. The truck moved, and the truck is here somewhere. The truck traveled exactly 1/3 the distance between the two vehicles. So the distance between the two vehicles, the truck travels 1/3 the distance between the two vehicles. So it's nice to put 3x here, right? And put an x here. That means the truck has traveled, when the truck travels x, then this distance here is 3 times that one. Okay. But these two together gives you 4x, and this thing is halfway. So this part from here, from the start to where it is here, is 4x, and that's what I got here now. You got 4x and 3x, and there is x there. All right, so now we've got the situation. Now, what is very important here is that, yeah, when car covers 4x, it covers 4x, t covers x only. So that's very important. Car travels 4x, t travels, covers only x. That is, c its speed is 4 times the speed of the truck. So a nice way of writing the speed is v for velocity, and put a c here, which means this is the speed of the car, and that is 4 times the speed of the truck. So the speed of the truck, sorry, it's 4 times the speed of the truck. So you got this equation here. Vc, the speed of the car, is 4 times the speed of the truck. Let's hold that in deep freeze. Now, let's go on with this question. I don't have much space, so I'm going to delete that. All right, now, okay, that part is finished. Now they say after 36 minutes, the car and the truck met each other. All right, they are still moving towards each other. The car here, the truck here. The distance they are traveling is 3x now, right? Because they are 3x apart. And they meet somewhere in between, and they meet after 36 minutes. The car is traveling faster, so the time taken here is 36 minutes. So now we want to know exactly where this is. Now this is very, very interesting. You see, the distance covered by both of them is 3x, and this car is traveling at 4 times the speed of the truck. So the truck would have covered only 1/5 the distance, and the car would travel 4/5 that distance. See? The distance between 3x. Right? Because he's traveling, the two will add up to 3x, right? And so the ratio of the distances will be 1:4, because so you want to divide this thing here up in the ratio 1:4, which means this is 1/5. That's how you got 3x over 5 here, right? This part here is 1/5, and this part here is 4/5 of 3x. That's how you get 12x over 5. Okay. If you don't understand that, you can say, let this be A, let this be B. Then you get A plus B is 3x. And you know that B is 3A, 4A. Because the distance the car traveled will be 4 times this. So B is equal to 4A. So A plus 4A is 5A. 5A is 3x. and A will therefore be 3x over 5. That's exactly what I said. But it's easier to think of it in the form of in proportion. It would be 1/5 the whole distance. All right, so that's how you get A, and then similarly, B will be 4 times that, which is 12x over 5. So now we've got these distances to see where they are at a certain. So they meet at the spot here. So this is what we got here now. I should have drawn this in. So let's see what happens from this point onwards. So now the truck and the car are together. The truck and the car are together here. And this distance here is, you have to add x and 3x over 5. To see where they actually meet. And that is 5x over 5 plus 3x over 5. So this is 8x over 5. All right. Okay, so they are 8x over 5 from this. So what happens here now, this truck is still going in this direction, and the car continues to go to this direction. So what happens now? They continue their ways. If the car turned around immediately after reaching the point A, so the car goes all this way and it turns around, how many minutes after the meeting will the car pass the truck? So the truck is going on like this. And at some point, this car turns and goes back and meets the truck. So now we want to know what happens here. So I don't know how far the truck has traveled. So let's call this Y. So when the truck travels Y, they meet here and they meet here again. So when the truck travels Y, what is it, kilometers or whatever, Y, this car would have traveled that distance plus, it goes, turns and comes back. So the T covers Y when the truck covers a distance of Y when the car covers, now it's double this, the 8x over 5, it comes back, so it's 16x over 5, double this, plus that Y, whatever the truck has covered, and this is where the truck and the car meet. And so now that tells you something, because what we are saying here is that, but the speed of the car is 4 times the speed of the truck. All right. So when the truck covers Y, it means 4 times that distance will be equal to 16x over 5 plus y. The car would have covered 4 times the distance that the truck covers. We saw that. The car travels 4 times the distance that the truck covers. So now you've got an equation here, which makes it 3x. Bring the y's to one side. 3y equals 16x over 5. So y is 16x over 15. Now they want to know after how many minutes will this happen, right? So the minutes will be y, the time taken will be the distance that the truck travels over its speed, Vt, right? Now, here's something else. You see, it took 36 minutes. We haven't used this here, the 36 minutes. It took 36 minutes for the car to meet the truck. So the car's speed, it travels 12x over 5. The car's distance, the distance that the car travels is 12x over 5, and the time that it takes is 36 minutes, which is 3/5 of an hour, right? And therefore, its speed will be this. The speed of the car is the distance it travels divided by the time. Now, when you do this, you'll see that Vc is 4x. So Vc is 4x. If Vc is 4x, then Vt is 4x. And that implies the speed of the truck is x, because Vc is 4 times that. So therefore, we've got time is y over x. And there you've got y divided by x is 16 over 15. I'm sorry, it's all squeezed in here. 16 over 15 hours. And 1 hour is 60 minutes. So 16 over 15. 15 goes exactly into 60, 4 times. So this is 64 minutes. It's a hard problem, and it'll be very useful for you to redo this thing many times over, right? And get a full understanding of what's going on here. Okay, so you have to do it piece by piece, and there's a lot of information in this, which needs to be sorted out. Okay, unfortunately, I didn't have enough space, so it became quite squeezed up in the end. I apologize for that. All right, let's get on to the next problem. Oh, all right. Now we finished the distance time problem. It took me 45 minutes to do this, so I don't have too much of time, but we'll see how far we can go. The distance time problem, as I said, even the last time, they are the most difficult problems that people have to contend with. But they're very interesting. And there's only one formula, and that is distance is equal to speed times time. Okay, now we go on to actual session 5 problems. Right. So let's look at the first question here. This question says the diagram shows 2 parallel lines with 6 points indicated. Right, 4 at the top. Okay, you can't see them very well. Let's just highlight these 4 points. 4 at the top line and 2 at the bottom. Those are the 6 points. How many triangles can be drawn with their vertices chosen from these 6 points? So what do we want to do? We want to draw triangles. The vertices must be chosen from this. All right, if you're drawing a triangle, the triangle, you need to have 3 vertices. Okay, so where are the vertices? You can't have all 3 vertices here because they're all on a straight line, right? So you could have 1 vertex here, or you could have 2 vertices in the bottom line. So there are 2 possibilities. Either you have 2 vertices here or 1 vertex, right? There must be 1 vertex on this line. Okay, so let's take those 2 cases, see what happens. Okay, suppose you got one vertex here. So let's suppose this is a vertex. Then what happens now? How many triangles can I have? We're counting the triangles with this as vertex. Well, you can choose to do this. You have to choose two vertices from four for this vertex here. Choose two from four. Select one vertex from the lower line. So how many triangles have you got? Well, you have to choose 2 points from there to create the triangle. Now, how many ways can you choose 2 points from these triangles? If you name these points A, B, C, D, you can choose it as AB or AC or AD, AB, AC, AD, or you can choose it as BC, BD. I think we've done similar things like this before. BC or BD, or you could have CD. Right? So there are 6 ways in which you can draw triangles. So there are 6 triangles with this as vertex. Right? For both? No. Right. So therefore, total, if one chosen from lower line right. If I choose, for one of them, I've got 6. For the other one, I've got another 6. It's 6 plus 6, which is 12. Now, this is where you choose only one vertex from the lower line. But now the second one is where you choose 2 vertices from the lower line. But now you only need one more. So you can choose that one to get a triangle. Right? If you want to see what triangle it is, sometimes people want to see exactly what you're doing. It's that triangle there. Okay? Right, so that's one triangle. Then you can have that point as the third point, that point as the third point, that point as the third point. So there are 4. For 2 vertices, you'll get 4. 4 triangles. So the answer is 12 plus 4. If there's one vertex, if you choose it from the bottom, you get 12. And if both vertices are chosen, 12 plus 4, so that makes 16 triangles altogether. So these are counting problems. You have to sort of have some systematic way of counting the total number. Don't just go randomly and try to draw the triangles. To draw 16 triangles in this little space here, you'll get into a complete confusion. You know, so you without see, I just demonstrated one triangle, but I'm just counting. I don't draw the triangles. I just count how many there are. So these are so this is from first principles. You can count them. Okay, let's now get to the next problem. We're into question 2 now. Okay, consider an 8 by 8 empty chessboard with 64 squares. So I've drawn the chessboard here. In how many ways can you place one black rook and one white rook on two different squares that are on two different rows and two different columns? All right, now before I go on, I want to say something. I suspect that I have said this thing before. I can't remember. But there's a very, very important principle that we will use over and over again in counting problems. So listen very carefully. Okay, so let's take a scenario. Suppose you got, I'd always like to take this example. Suppose you got three towns and you've got two roads from A to B, and you've got four roads from B to C. And you're traveling from A to C. How many different pathways can you choose? How many different routes? Right. The logic is followed. No, is important. Now listen carefully. The first road can be chosen in two ways. Right. Now, for each choice of the first road, I got four choices for the second road. So for this road here, I've got four different pathways. And for this, I've got also four different pathways. So therefore, the number of pathways that you have is 4 plus 4, if you like, but it's really 2 times 4. Because for each choice of the first, you've got four choices of second, and there are two ways in which you can choose the first. Therefore, there are 2 times 4 ways of choosing the second. I usually put this into a little block like this to say the first one can be chosen in 2 ways, the second one can be chosen in 4 ways. For each choice of this, I've got 4 choices of the second, and therefore the total is 2 times 4 equals 8. See, if I had 12 routes here, right, and 14 routes here, then again you have the same argument. For each choice of this, you got 14 pathways, but there are 12 ways of doing this. So in that case, it will be 12 times 14. Now you could have had 3. You could have had another one here. Right? So then you will say, I've got, to get to this, I've got 8 ways of getting to this. And there are 3 ways of getting to that. So for each of these 8 ways, I got 3 ways of reaching my destination. So therefore, it will be 8 times 3. Right? So it's actually that times that times that. See? So if you got 3 different routes, you say, in how many ways can I do the first? How many ways can I do the second? How many ways can I do the third? And altogether, it'll be that times that times that number of ways altogether. It's a very, very important principle. Right? Right. It's called the counting principles. Right? The one with only 2 times 4 is called the first counting principle. And if you got more than 2, it's called the second counting principle. And these are what you would learn in grade 12 or grade 11 when you're doing a subject called probability. This particular fact will come up. Right? Very, very important. It's in your syllabus. Okay. So in this particular problem, it says here, in how many ways can you place, again, it's a counting problem. And the question is, how many ways can you place one black rook? A rook, I don't know whether you know what a rook is, but it's a chess piece. So I'm going to place a black rook anywhere here. I got 64 choices to place black rook. Right. So once I placed that, I got 64 choices. So I've got my little thing here. And one white rook. So I'm only going to place one white rook on two different squares that are on two different rows and two different columns. So if I place the black rook here, I can't place the white on this column in which the B appears. Right? It says on two different squares, on two different rows and two different columns. So I'm not allowed to place the white rook anywhere here and anywhere here. So in how many ways can I place the white rook? All right, so you have to eliminate all these. It's the 8 squares here. And it's actually not 8, 8, 7, because the black rook is already placed. So it's 8 plus 7. There are 15 blank squares here. You're not allowed to put the white rook on any one of those 15 squares. Right? White W cannot be. Sorry, I've got a problem with that pen. Sorry, I've got a problem here. The pen stopped writing. Hmm. I wonder what happened. It's never happened before. Um, Sorry, let me just try to figure out what's going on here. Just give me a bit of time. Nothing is working. Khotso, can you hear me?
Yes, I can hear you, Prof.
Okay, can you just stop recording for a moment?